Hey, this is Steven from Legit Tech Tutorials and the Green Engineers. Ooh, we have a new update. August 22nd, 2019. Interior design, anything new? No, looks like some just hot fixes. Yeah, just hot fixes. So it looks like we just have some hot fix update. Nothing crazy in Fusion for August 2019. I'm gonna open up my window a little bit here. It's super hot in here again. So, basically, we are back working on the hopper on the shredder. It's progressing through probably this next week. Hopefully, Friday or something, I can get the machine. I'll have to talk to them about that. I mean, really, I would like to build it over the weekend. But we will see. So we'll see when I get that actual sample, and then hopefully from there I could build it and run it a little bit with the breaker bar. The issue is that I no longer have access to a lathe. So, because originally one of my ideas was I was just gonna put a big bolt on here on one side, and then basically just put a big hex head on there, and then kind of use that to move it. Maybe I could put something on there that adapts the square, or have something machined that adapts the square to like a 1/2 inch breaker bar, or maybe I could find some sort of socket that I could put on there that will go on here without rounding the socket out. Or maybe they have a square socket. I don't know. We'll see. Anyways, so this has got nothing in it. That's great. So let's go here. Let's drop in shredder assembly as the usual. So let's go ahead and go here, and we're gonna rotate. Okay, cool. Hopper wall. Okay, so now obviously we got it to do what we wanted it to do, but we need it to meet in a certain spot. So we need this to probably be even wider than 12 inches. Because we want it to be 12 inches by 12 inches, so it's probably going to have to be wider here, or not as tall. Because right now it's really tall, I think. I think it's 12 inches tall. It should be 12 inches tall. This is 12.16, but I believe from here to there it's less. So, how are we good? What I'm thinking right now is the best way of doing it is really to just do planes, and then we have it basically have to be all one unit. So what do I mean by that? What is this? Yeah. Okay, so let's see what happens if we do that here. So let's say that we put those bars on there from the stand. Let's put the mount. And then technically the mount's actually going here, right? Sure. So it does actually look like it's upside down, but that's okay. We're going to turn off joints. Put the mount back over here. And we're going to rotate this. Okay. Oops. Cool. Oh. What the heck? Man, some of this, they need this bug fix. I should really be sending this kind of stuff to these guys. To these Autodesk guys, because I mean, they see a lot of the bugs. Any sort of issues with the bugs or some sort of weird stuff. Because I do not think it should be doing that. Don't move. Okay. Now, that looks good. Okay, so, but now, basically, we're going towards the bottom, but that's okay. Now, basically, what we're going to do is, and those pieces, of course, like I said, are either going to be underneath or on top. Probably on top. Or maybe even underneath. I mean, I would like it to go inside, but obviously you can't do that. I mean, it's going to be outside, so I might be able to put maybe some printed things in the corner, something that sits along this to kind of have some sort of adapt the two together instead of having this thing go inside. We'll have to see. I mean, I don't think it's really that necessary. You're going to have some pieces get stuck on the shoulder right here, so maybe 3D printed piece that goes around here is probably necessary. But we'll see here. So now basically what we're going to do is we're going to do this here, and we're going to do a rectangle, and we're going to project this, basically most of the stuff here. And we're going to say okay, and we're going to project a rectangle from here to here. And then we're going to say, and then we're going to do offset that rectangle. And then we're going to offset 0.060, which is 16 gauge, I think. Yeah, 0.060, 16 gauge. Ooh, but it's not where it needs to be. So let's say we're going to do an extrude from here to new body, from here to object, from there to there. Okay. Now obviously you see it's gonna be hitting here, so that looks good. Then we need to do a new plane that's 12 inches higher. So let's do another sketch plane, and that's 12 inches up. What the? Oh, yeah, you can barely see it. Okay, so then we're gonna go here, and then now basically what we're gonna do is we're gonna project this, actually pretty much this. And then let's see if we can find center. Yeah, we're gonna need to do artificial center. That's what I thought. So from here to there, and from there to there. Artificial center, and we're gonna do a rectangle center point, and then we're gonna do a 12 by 12. That's a nice hopper. Okay, finished sketch. Ooh, not finished sketch. And then basically we're gonna do an offset here, and we're gonna offset that 0.060. Alright. This is probably how we definitely should have done it the first time. So now when we finish sketch, we're going to loft it, basically. Loft from here. Wait, maybe I could open up the first sketch. And then let's hide this body. Okay. So then let's create loft. And then if it wants to, we'll open the body up right at the end. There it goes. And then join. Did it loft the whole thing? I think it lofted the whole thing. Did it? Let's see. Inspect section. Turn off this. Yeah. Okay, so I mean, there's the other way of doing it. That's one way of doing it. Oops. Yeah, we want to hide that. We want to hide the analysis. And let's do modify shell 0.060 inside. Okay, so let's go ahead and hide that, and let's take a look. Ooh, so we have an issue here. So basically this is probably just going to have to be a band. So let's say here we do just a band. So we go from here. I'm just going to project this. And then let's do a band. Quarter inch 0.25. There we go. And we're basically just going to cut away to minus 0.060. There you go. And that looks good. And same deal here. Project here. Do a band. Quarter inch thick. And then probably welded here, or maybe even, I could even draw like a shape here so it stays nice and strong. We'll look at it. So basically a shape here that goes here and then like down. So basically all this shape but offset. So here offset. So this shape that I drew, but this is offset. And then I could cut that out with a little cutoff wheel or whatever. Or when they're cutting it on the water jet or whatever, then they could do that. Okay, so that is a big hopper. Okay, so what I want to see here, let me see shell. So let's go back before the shell, and let's look at what this volume is here for this body. So this is, let's call this the hopper. What is the volume? Properties. Volume 1072. So basically what I want to do is I want to look at, let's say we take this guy and we say physical material, temporarily, let's say plastic ABS, and then let's look at the physical properties, and we have 657 divided by 16. So that'll hold about 41 pounds of plastic. Obviously, that's assuming that the plastic is, what's the word I'm looking for? you know, completely fills that up. But yeah. And so let's go forward. Oh, it looks like there's a skin there on the floor. Oh, yeah. Let's see. Cut that through. Back there. There we go. Cool. And there we could see the sheet metal. So there's that piece. Sheet metal here. I think that would be good. So 12 by 12. Can you fit a milk jug in there though? Where's my tape measure? Jake use it? Oh yeah, I told Jake to use it in my brother Jacob use it in the other room. So I have another one over here in my nightstand. Okay. Oh yeah, you fit a milk jug in there. 12 inches, you definitely fit. I mean, you can't fit many of them, but you could fit one at a time. And some other stuff in there, milk jug and some other things. But water bottles. Oh, I do have one in here. My brother left it. I personally don't drink water bottles at home. I just use a container or whatever. So this is 3 inches. So we can fit quite a bit of these. So this is 3 inches by 8 inches. So you can fit a couple of those in there. I mean, it's going to jam up, but at least you don't have to really hold it. So, I mean, this will work. You jam it pretty full. I mean, I think I would rather have it be kind of wider, but then it doesn't fit in the box. Because I think it does need to be a little wider. And then, oop. It does look very like, it does look like it's very, like too tall. Yeah, it's about an inch too tall. Yeah, I forgot to count for this, but basically I could make this 11 inches. I think it'll work. I mean, it'll fit in the box. I could probably change it a little bit. So now the next idea pretty much is to take like the difference between these two and then punch an angle through here. But basically what I could do is I could do this. So one of the things that I was thinking is either doing this and then I could weld here. But then, well, if I weld, then it's basically fixed. What I'm thinking is that this thing doesn't need to be super rigid, because originally I was going to have like some tang, basically like a tang that stuck out of this one, and a tang that stuck out of this one at 45, so 45, 45, and then they basically, that's where they join, and you just bend those at 45, so 45, so 45 out of this one, 45 out of this one, and then the two come together and you bolt it shut. But the question is, how strong does this really need to be? I mean, obviously it's not going to be like this. It's not going to be, you know, together. Unless I have some sort of bracket, something that I attach here or whatever, or I weld it somehow. And then these obviously have this hole go through there, so you bolt that through. And then this needs to be, that's a good question, what angle is this? This is, so it's going 180 minus that, that's 5, 7, that's 15 degrees. So it's got a 15 degrees up angle. At least a round number. I mean, it's 15, a little less, but that's fine. So how to do this, how to do this. I'm thinking I'm going to have the tang that goes down 45 off. Let's see what happens. So let's create offset. Not that kind of plane though. Offset. plane at an angle. I have a plane at an angle. So let's go down here. And let's click on where. This one. Not that way. This way then. Okay, so then let's rotate this guy 45. Toggle the visibility, construct. Okay, so basically I'm in line with it. Okay, so let's go here. Whoa. Okay, there it goes. Okay, so now I'm looking right down it. So let's see, how am I going to go about doing this here? Where's my coordinate system? There we go. Yeah, okay, cool. So basically I'm going to go here and I'm going to project this and this like so. And then basically I'm going to have some sort of angle down, let's say between these 2 points here, 45. And the distance from here to here is some number, let's say, 1 inch looks pretty good. Okay. And then we have a 1 inch tang go down and do the same deal here. This is 45. 45, and then we have a distance here of, oops, and then we have a distance here of 1 inch, and then it goes from here up to here, and we make this construct. And basically that's pretty much what we have. Right, and then let's finish sketch, extrude. Then we wanted symmetrical, 0.060. Doing. Uh-oh. What happened here? Something is twisted. It's weird. I mean, you kind of get the idea. It needs to come from inside the sheet too. Oh, basically I could put a radius in there. But why is it not? It's very strange. It's 90, so this, I mean, this should be, oh. Does it get more as it goes up? No. Okay. Okay. So basically this has got to be negative 46.75, negative 46.75. Okay, now what does it look like? Okay, now it's in line. I think it's just offset now. Very weird. Let's see, let's jump in the sketch, see what it looks like. Yeah. What if I do, oh, I know what I need to do. I need to do construct plane along path. See if that will do it. Well, not that specific path, then I guess it's this path. Plane, it's going to be like plane through path. I don't want to continue to face. Very strange. Okay. So basically, let's delete that. Delete that. Let's delete that. Okay, but now theoretically we should be good. So let's do the same deal. From here up, we have. From here up, we have 45 degrees. And we have dislocated here. There we go. From here to there. This is 1 inch. And from here to there. This is 45 degrees. Whatever. Inch, and this goes from here to there. It looks good now. So now I want this just as two sides symmetrical. 060. Join. There we go. Okay, and then basically what we do, we're going to fill it between this face and that face. Okay, so basically what we're going to have to do is we're going to have to go inward slightly. 0.025 or whatever. Go all the way up here. If you project that. Now it's ginormous. I should really learn the sheet metal. I might have to mess with the sheet metal a little bit better. Yeah, I think I need to learn the sheet metal. That might have to be next video, because I mean this has to have a certain bend, and it would be nice to have flat, and then so I could kind of have them, you know, score the lines or something, laser etched lines to show me where to clamp down on and bend, you know, 15 degrees, blah blah blah. When I have them laser cut or I water cut, and I could shoot with a water to etch it or whatever. So we'll do that next video. So that will be Monday, as today is Friday. Well, now it's technically Saturday. So I think that's the best way of doing it. But here we understand kind of what it looks like. But now we need to have a way of making it a little bit more rigid. These are where it's going to be held, and then basically this rib is what's going to hold these two pieces together. And then maybe a bracket thing that goes across and goes up to this point, so it kind of sturdies this up a little bit. So we'll see. Okay, so this has been Steven from Legit Tech Tutorials and the Green Engineers. I'd like to thank you guys for watching, and I will see you guys after the weekend. Thanks for watching. Take it easy. Peace.